Imagine plunging into the depths of the ocean, far beyond the reach of sunlight, into a realm known as the Twilight Zone. This mysterious part of the ocean, between 200 to 1,000 meters below the surface, holds secrets that scientists are only beginning to uncover. Welcome to the ocean's Twilight Zone. The Twilight Zone, also called the Mesopelagic Zone, is where light barely penetrates. Creatures here live in a world of shadows, relying on bioluminescence for survival. But what exactly makes this zone so unique? The creatures in this zone have adapted to survive with little light and immense pressure. Fish like the lanternfish use bioluminescence to communicate, attract mates, or hunt for prey. Their glowing lights are nature's neon signs in the darkness. This natural glow isn't just for beauty, it's a survival strategy. Some animals use it to blend into the faint light from above, making it harder for predators lurking below to spot them. Even though it's a mysterious realm, the Twilight Zone plays a critical role in Earth's ecosystems. It's a key part of the ocean's carbon cycle. As marine snow tiny particles of dead plants and animals falls from the surface, much of it gets consumed in this zone, preventing it from reaching deeper. Without the Twilight Zone, the balance of life in the ocean and possibly the planet would be dramatically different. From bioluminescent wonders to its crucial role in Earth's carbon cycle, the Twilight Zone remains a world we are only beginning to explore. What other secrets does it hold? Stay curious and keep diving deep with us. Make sure to like, subscribe, and hit the bell icon so you don't miss our next exploration into Earth's hidden realms. Let's dive down into the ocean. Start by imagining you're floating on the surface, basking in the sun of a hot day. Next, dive. First 50 meters, then 100 meters, then 150 meters. In this imaginary exercise, you have amazing, inhuman lungs. At the beginning of the dive, you're in the ocean's epipelagic, or sunlight zone, the shallow waters where light still penetrates and photosynthetic organisms live. But as you dive deeper and deeper, the sunlight above you fades. The ocean around you gets darker and darker, colder and colder. At 200 meters, you enter a new division of the ocean. It is the middle ground between light and shadow, an area which scientists call the Twilight Zone, or, when they're being technical, the Mesopelagic Zone. And if the televised Twilight Zone lies somewhere between the pit of man's ignorance and the sum of his knowledge, so does the one in the ocean. It's almost easier to define the ocean's Twilight Zone by what we don't know, says N1 Lavery, an acoustician at the Woods Hole Oceanographic Institution who has been probing the Mesoplatic's depths for years. The Twilight Zone extends across all oceans on the globe. It's so big and difficult to access, it does not lend itself easily to being studied. It's remote, it's deep, it's dark, it's elusive. It's temperamental, she says. As a result, the Twilight Zone is one of the more poorly understood ecosystems of the Earth. It's important that we try to learn more, because this ecosystem may be critical, and Doan and her fellow researchers suspect that it plays a crucial role in regulating the climate. But the scientists who are studying the Twilight Zone are working against the clock, because commercial fisheries have also taken an interest in the region. On this episode of the Unexplainable podcast, we ask, can they learn enough about the Twilight Zone to help fisheries fish it sustainably? Before it's too late, the Twilight Zone is so mysterious, we don't even... For one, it's home to a lot of life. In 2014, a paper came out suggesting that there might be 10 times as many fish living in the Twilight Zone as was previously suspected. That would mean that there were potentially more fish in the Mesopelagic than the rest of the ocean combined. This new number is just an estimate, however, and could have its own measurement problems. Lavery laughs, explaining that the one thing she can say for certain is, there's a lot of fish living down there. Another thing we know, every night some number of those fish, along with many other non-fish organisms, rise up from the Twilight Zone to the surface of the ocean in order to feed. Then, they sink back down to their dark ocean home in the depths. It's been called the greatest migration on Earth, says Annette Govindarajan, a Hui oceanographer who also does Twilight Zone research. This process was originally discovered back in the 1942, when Navy-affiliated researchers were testing out different methods for detecting submarines. They were using sonar, sending out pulses of sound and measuring their reflections. Normally, the strongest reflection should come from the very bottom of the ocean. But their measurements kept picking up a false bottom, much higher up than expected. This was a layer of life in the Twilight Zone, so dense it appeared like the floor of the ocean. And that layer was rising and falling each day. Simon Thorold, an ecologist who studies the phenomenon, describes the motion of all this rising and falling life as like a kind of breathing. Like a diaphragm, he says, driving the very breath that the world is taking every day. The Twilight Zone may play a huge role in storing carbon from the air. Deep in the sea, breathing analogy is especially apt because this migration may play a big role in our atmosphere's carbon cycle. Scientists don't have a concrete number, but it's possible that migrating creatures help take 2 to 6 billion metric tons of carbon out of the atmosphere every year. That's a big number. For context, road vehicles account for about 3.6 billion metric tons of carbon dioxide every year. How could these creatures do this? The current thinking is that carbon dioxide dissolves in the surface waters. Some of it is taken up by tiny plankton. Then, when these migrating denizens of the deep come up to the surface, it's thought that they gobble up that plankton and then poop deep in the ocean later on. The carbon could therefore be sequestered in the poop. The life scientists have discovered so far in the Twilight Zone is wonderful. Researchers still don't know everything about life in the Twilight Zone, but they have made some weird, wonderful discoveries. For example, the zone may not be lit up by the sun, but it has its own source of light, a dazzling array of bioluminescent creatures that sparkle in the darkness. There are siphonophores, living colonies of jellyfish like clones all strung together in long chains. They can grow to incredible lengths. The longest found so far was estimated to be 150 feet. That's longer than a blue whale, the largest animal on Earth. There are anglerfish, familiar to some as the scariest thing that happened in Finding Nemo. Anglerfish females dangle a flashing blue-green light, also known as an escape, in front of their faces, which beguiles prey animals like a will-o-wisp until they come close enough to be devoured. Also, some anglerfish can retract their teeth, and anglerfish stomachs can expand and their bones can flex so they can eat organisms twice their size. Have a good nightmare. And then there are the chameleons of light, the fish and organisms that use countershading, a form of camouflage. At 500 meters, Thorold explains, everything would seem pitch black to us, but there is still some measurable light from the sun trickling down or downwelling. If you're a predator, swimming below a prey fish, Thorold says, you look up, and you've got very sensitive eyes, so you will see that silhouette of that fish. So the prey fish use bioluminescence to hide, to blend in with the faint sunlight. Their bellies are studded with photophores, organs that produce light, and they use those organs to match the light downwelling from the surface exactly, disguising themselves. It's hard enough to match that intensity so well. That's cool in itself, Thorold says. But what's even more remarkable is that these fish also match the color of the light filtering down, which can change slightly depending on depth. And these chameleons don't stop there. Once they've done the work, they may drift up and down so they don't have to start over again. If the sun goes behind a cloud, Thorold explains, we think that these fish will actually move up in the water column as the cloud is passing in front of the sun to make sure that they maintain that exact match of light as that cloud goes past. And a little bit scary, this is the prembug, scary, fire ride and scround except. When these Twilight Zone crustaceans catch their prey, they slice them open with their claws, chew out their insides, and move in. But wait, it gets scarier. The females of the species lay their eggs in the hollowed-out remains of their prey, then clamber back out again and push the husk full of eggs around like a baby pram. And attractive to Praterway swid your support to Daindependent Journey Match Maritidi Chermani Mes Sport Independent Chananani Mes Marchame. Vox is here to explain this unprecedented election cycle and help you understand the larger stakes. We will break down where the candidates stand on major issues, from economic policy to immigration, foreign policy, criminal justice, and abortion. We'll answer your biggest questions and will explain what matters and why. This timely and essential task, however, is expensive to produce. We rely on readers like you to fund our journalism. Will you support our work and become a Vox member today? It's deep, it's dark, it's elusive. The ocean's twilight zone is full of wonders. Scientists are probing its depths. So are commercial fisheries. Bird Pinkerton is a senior producer and reporter on Unexplainable, Vox's science podcast. She covers everything scientists don't yet know but are trying to figure out. So her work explores everything from the inner workings of the human body to the distant edges of the universe. Let's dive down into the ocean. Start by imagining you're floating on the surface, basking in the sun of a hot day. Next, dive. First 50 meters, then 100 meters, then 150 meters. In this imaginary exercise, you have amazing inhuman lungs. At the beginning of the dive, you're in the ocean's epipelagic, or sunlight zone, the shallow waters where light still penetrates and photosynthetic organisms live. But as you dive deeper and deeper, the sunlight above you fades. The ocean around you gets darker and darker, colder and colder. Amanda Northrop Vox at 200 meters. You enter a new division of the ocean. It is the middle ground between light and shadow, an area which scientists call the Twilight Zone, or when they're being technical, the Mesopelagic Zone.